Here's a quick example of moving from the idea of annual compound interest to monthly compounding. Let me review real quickly what the simplest case is. That's where you have an annual interest rate R and it's compounded annually. No funny business about monthly compounding. What you get is that you take your money P and you repeatedly multiply it by a multiplier. It's as if you're actually magnifying your money by a factor of 1 plus R, 1 plus the interest rate. If you repeatedly multiply it t times over t years, you're really multiplying it by 1 plus R to the t power. So that's really the fundamental formula. And then it just gets a little bit more modified when we look at different compounding periods, for example, monthly. Okay, so one note, I've started using a capital R for the interest rate. And that's because this number 1 plus R is so important, and that's really the ratio between the amount of money you have this year and the amount of money you had last year. Or we could think of it as a multiplier. Like I said, it's the amount the money gets multiplied by repeatedly. And later on, it makes a lot of sense to conform with a lot of mathematical cool stuff to denote that by a little r. So that's why I'm using a big R for the interest rate, not a little r. And in fact, little r eventually becomes something different. Okay, so, but you don't have to worry about that right now. It's just I'm using a big R for the interest rate. So for example, $1,000, principal of $1,000, put in at 6%, we're going to get A of t is 1,000 times, now let's see, what is that 1 plus r? So that's 1 plus 0.06 to the t. Or in other words, just simplify that, how we're writing it, 1.06 to the t power. Okay. So for example, A after 10 years, for example, would be 1,000 times 1.06 to the 10th power. And that's a pretty decent increase. Let's evaluate that. That's going to be $17.90 and 80 cents. Let me put that back where I want it. So hopefully that's familiar at this point. Let me put the extra decimal there. Okay. But what is this monthly compounding business? It's not super complicated. What you do is, let's suppose you have the same amount of money and the same advertised interest rate, but all they say is it's monthly compounding. What you do is you take that annual interest rate of 6%, and they're just going to give it to you in installments. Now, of course, they're not going to give you the full 6% 12 times. That would amount to a 72% annual interest rate, or maybe a little more. But they're going to take the 6% and split it into 12ths. Okay, so the monthly interest rate is then 6% over 12, or 0.5%, or if we need to put it in terms of a raw decimal, 0.005. Okay. And then they're just going to give you that much money, the 0.5% of your money extra every month. But then it's the same thing as what we had before. It's the same idea of repeatedly multiplying. So what are we going to get? We're going to get, after t years, we're going to get that A of t is $1,000 times this new multiplier, which is going to be 1 plus just 0.005. Not very impressive. That's a number that's pretty darn close to 1. But every month, which is 12 times as often as we had before, every month they're going to multiply our money by that amount. So you might think, oh, okay, I'm just going to raise that to the t power. But that's the other thing that changes. Okay, I'm still using the same units for t. I don't want to change my units. I don't want to change how I talk about the interest rate or the units. I want everything to be in years. I want that to be the whole monthly compounding thing to be kind of hidden, really, and not have to worry about it. So I'm still going to count t in years, and so this needs to change, because if I've had it in for 10 years, for example, they haven't just updated my account 10 times and given me money 10 times. They've done it 120 times. So it's pretty simple. What you do is you just convert the t years to months by multiplying it by 12. Okay. And so that is going to be 1,000 times 1.005 to the 12t. Okay. In general, let's get a number. For example, let's compare. It's not going to be dramatically different from what we had before, because monthly compounding doesn't usually have a huge influence. So 120 months have gone by. I've gotten 120 monthly statements in the mail or in my email saying that they've updated my account by a little bit each time. And how much are we going to get? 18, 19, and 40 cents. Okay, and that as compared to 17.90 and 80 cents. You get a little bit more money. It's worth it. It's nice. It's 30 bucks extra basically. So what's our master formula looking like? Very similar, not capital T. You take your initial principal. You create your multiplier by taking that annual interest rate, converting it to a monthly interest rate, adding 1 to make your multiplier, and then using that multiplier, the number of months that you're using it, and that means 12t. Okay, so notice that 12 shows up in 2 places, and we'll generalize this a little bit to compounding a different number of compoundings per year, but I just wanted to do the simplest case and very, very common, which is monthly compounding. If you want to see it on a spreadsheet, for example, this is how that would look. Let me change that back to 6%. Okay, you would have something where in each year you start with a certain amount, you get a paltry amount or a fairly small amount of interest just each month. At the end of the month, you have a little bit more money, and then it updates and you get a little bit more money. It updates, you get a little bit more money. It updates, you get a little bit more money, and it starts to grow. So for example, if we took this out really far, 6%, again, not a ridiculous interest rate, all pretty good for right now, 0.5% monthly interest, in other words, a multiplier of 1.005, you actually, after 45 years, say this is like a retirement account, you got almost $15,000 in there. That's not bad, starting from $1,000. Okay. All right, so that's it.